last time, and we still had to do the ones where they said like solve for the indicated variable. So we're going to go ahead and do those ones. So on these types of problems, it's exactly like the ones we did before where we had numbers, okay? So if we're solving for h, like number 1, we want to get the h all by itself. So we want to do the opposite operation to get the other things to the other side, okay? So the first thing I could take care of is that 1/2. And I could divide by 1/2, but it's really the same as multiplying by 2, right? So we're going to multiply by 2 on both sides. So when I multiply by 2, I'm going to have 2a. That 1/2 and the 2 are now cancel, right? They're gone. And I'm going to have h times b1 plus b2. Okay. Now, a lot of you might be tempted to go ahead and distribute. I think you see the distributive property so much that you just like automatically do that. But if we're solving for h, you guys see how we're going to take that whole chunk, the b1, b2, and we're going to take that b1 plus b2 and we're going to divide it over. So our answer is going to be 2a divided by b1 plus b2, and that's equal to h. Okay, so we needed to get rid of it by doing the opposite operation. So since we were multiplying by b1 plus b2, we divided it over. Okay, have you guys done these before? Yeah. All right, so the next one, so I have v equals 1/3 pi r squared h. So let's go ahead and get rid of the 1/3. So what am I going to multiply by on both sides? 3. So I'm going to have the 3v equals pi r squared h. So if I'm trying to get rid of, or trying to get the h all by itself, I want to get rid of that pi r squared. And the pi r squared is being multiplied by h, right? All of it's being multiplied. So we can actually divide that whole chunk all together. So we're going to divide the pi and the r squared to the other side. So when we do that, we have 3v over pi r squared equals h. Now, if you had done one thing at a time, it's a little bit messier. So let me kind of show you that. You would have done like 3v over pi, but then you'd still have r squared h. And then you'd have to divide by r squared. So see how that kind of creates like a fraction within a fraction. So it's easier to do it all at once instead of thinking, okay, I have 3v over pi divided by r squared, so I'm going to flip it, so it's 1 over r squared, you see? So it's just a little bit easier if you do that all at once. All right, and the next one, so this is where it gets a little bit tricky. So we want to solve for x. Okay, so this one's weird because if you notice there's 2 x's. We have an x on the left side of the equation and an x on the right side of the equation. So when this happens, we have to get all of the x's, so every single thing that has an x on one side. So get all terms with an x on one side. And then get everything that doesn't have an x on the other side. So the quickest way of doing this is to take this xa here and bring it to the other side. So what operation do I need to get it to the other side? Subtraction. So I'm going to subtract the xa over. So I'm going to have 5y equals xb minus xa. Okay, and we do that for a reason, because if I'm trying to solve for x, I can't have an x on my other side. It needs to be like x equals and nothing with x on the other side. So I do this for a reason. I do this because I can pull out an x. I can factor it to the front. So you guys did a little bit of factoring in Algebra 1. This is factoring out a GCF. So we pulled it to the front. We will do much more factoring in Algebra 2. I don't know if that makes you happy or if it makes you sad. I feel like I'm a good factoring teacher, so if you don't know how to factor now, you will eventually. All right, so we have this. So now that you have the x pulled out, do you guys see what you're going to do to get the x by itself now?
Divide by b.
Yeah, divide by the b minus a, exactly. So we're going to have x equals 5y over b minus a. So that will always happen whenever you have like 2 x's or 2 y's or whatever you're solving for. You want to get them on one side, factor it to the front, and then solve. All right, so let's try it on this one. So we're trying to solve for a. So we're going to get everything that has an a on one side of the equation. So kind of do it along with me. So I'm going to subtract my 6ab to the left side. Doesn't matter which side you get them on. And then I have my b, and I'm going to add the 6b to the right side. So that right-hand side, I have b plus 6b, so I'm going to say 7b. All right, so I have 5a minus 6ab. So now I have everything that has an a on the left side of the equation. So I'm going to pull out the a, so factor it to the front. And when I do that, I'm left with 5 minus 6b. And you can check with the distributive property. We know we did it correctly because if I distribute the a in, I get 5a minus 6ab equals 7b. So if I'm solving for a, I divide that whole parenthesis part over. So I have 7b over 5 minus 6b. And we know we're done because we don't have any a's on that side. Okay, we just have a equals and then no a's on the other side. Okay. All right, now if you had done this a different way, so let's say you had originally, instead of like subtracting the 6ab to the left side, instead you subtracted the 5a to the right side. So maybe you do it differently. This is just something as you're checking your homework with your friends, you might do different. You could have negative 7b, oops, I don't know why I'm writing on that, negative 7b over 6b minus 5. So you could have that. So tell me what's different about that answer. There's a negative on the top. And what happened at the bottom, Karen? Yeah, it's just like multiplying by -1 over -1 on the top and bottom. Okay, so if you're checking your work with your friends on the ones that we're getting ready to do, and you're like, wait, I got the opposite on top and bottom, right? It's still the same thing, okay? It just might be in a different form, okay? So kind of keep that in mind that you could have a different answer. All right, and then word problems. So it says to solve a word problem, you need to first define a variable. So we'll be doing more word problems in section 1.7, but we're going to do a few here. So it says, in other words, you need to decide what we're trying to find, and usually that's going to be your variable, like an x or whatever. So then you can write an equation and solve. So this says, Asha wants to replace the 5 windows in her second-story window of her house. Her neighbor, Sai, is a carpenter and has agreed to help install them for $250. So if Asha has budgeted $1,000 total for the project, what is the maximum amount she can spend on each window? Okay, so we're trying to find the maximum amount she can spend on each window. So let's make that our x. We should always do a let statement. So we're going to say let x equal the max amount for each window. All right, so I'm kind of abbreviating there. So maximum amount is what that means. So maximum amount. All right, so she has 5 windows. He's doing she is doing a set fee of $250. So like the labor is $250. And we have a total of $1,000. All right, so who can tell me an equation to set up? Yeah, Gloria? Exactly. So 5x plus 250 has to be at max that 1,000. Okay. So that's including the labor cost. Now some people might have said 750 equals 5x. Do you see why they might have had 750 equals 5x? Yeah, they've already subtracted the 250 out. So it doesn't matter, so we have that. So let's subtract the 250 over. And we divide by 5. What do we get when we divide by 5? Do you guys know? Yeah, 150. So that means that when she's searching for windows, she doesn't want to spend more than 150 for each window because then she's going over budget, right? So she's kind of keeping that 150. That's my max amount for each window as she's looking. I usually try to put people's names that are in the class. So these are people at university, Ajda and Sai. But Jeff and Laura are not names of university people because I always find it weird in story problems when I make you guys like date. So Jeff and Laura, that's my twin brother and his wife. So they're arriving at the bowling alley. They have $16.75 for the two of them. Man, Jeff doesn't have much money, does he? The shoe rental is $1.50 each and the games are $2.50 for each person. Find the maximum number of games that they can bowl against each other if they rent shoes. Okay, so if they're renting shoes, then that means that we're paying $1.50 for Jeff's shoes and $1.50 for Laura's shoes. And then we have $2.50 for each person. So how much to play one game? $5, right? So we're going to do $5 times X. And what's X? Yeah, the number of games. And that can at most be that $16.75. Okay, so when we add the $1.50 plus $1.50, we get $3. And we're going to subtract that over. So when you subtract that over, we get $13.75. So when we do $13.75 divided by 5, we get $2.75. Exactly. So you should always think about what you're solving for. So in this story problem, if we have 2.75, the bowling alley is not going to let you bowl 2 full games and then say, we're just going to do 7.5 frames. Like, we're both going to go 7 times, and then Jeff's only going to go 1 frame, and then we're done. Do you think the bowling alley does that? No. So you have to think logically about the problem. So you can do 2 full games. So they can bowl 2 games against each other. So always think about it. All right, making sense? All right, we'll stop there.